Hi everyone. We are going to today take a second look at ambiguous case for sine law and go over that once again, this time focusing on what happens when we do have two solutions. So let's take a look at, again, this has to be for a side triangle, uncontained angle. First thing we look at is the size of our angle. So if we have an acute angle for our given angle, we are now going to compare the size of our sides that are given. So if A is less than, let's start with if A is greater than, so side A is greater than B, we have one solution. And this is just a review of what we talked about yesterday. If A is less than B, so A is shorter than B, now we have to compare it to B sine A. So side B times the sine of the angle. And if A is equal to B sine A, we have a right angle triangle. Side A is the height of the triangle, and there is one solution. If A is shorter than B sine A, that means it's never going to meet up with the other side, meaning that there is no solution. And if A is greater than or equal to B sine A, therefore here we have two solutions, one acute angle and one obtuse angle. The other side of the case is if we have angle A is greater than 90. Well, if A is shorter than or equal to B, there is no solution. It will not meet up with the other side. If side A is greater than, not equal to, so if side A is greater than side B, then there is one solution. Okay, so taking a look at a couple of examples. Example 1, we have angle A is 42, side A is 10.2, and side B is 8.5. So again, we do have a side angle, or side angle. So starting with our 42-degree angle for A, we know side B is 8.5, and we know that side A is 10.2. Well, in this case, since angle A, so we're going to first of all look at angle A. A is less than 42 degrees. Now comparing the size of our sides. A is longer than B, meaning that there is going to be one solution. Okay, right away, we know that this is longer than this side, so it can't swing over. If we were to swing this over, it meets up way over here, which doesn't create another triangle with that 42-degree angle. So we're going to go ahead and we're going to solve for angle B. So we're going to use our sine law. We know that sine B over B equals sine A over A, and we're going to use A because we have both pieces and B because that's what we need to figure out. So sine of B over 8.5 equals sine of 42 over 10.2. So sine B equals 8.5 times sine 42 divided by 10.2. Remember that what we're going to get here when we multiply this portion here is a decimal. It can't be greater than 1. We do our inverse sine to find angle B, and we can round to the nearest tenth. Question tells us to the 10th of a degree. So angle B is 33.9 degrees. Now, we want to also find angle C, but notice that we already have two of our angles. Way simpler to use 180 minus 42 minus 33.9 to find angle C. When we do that, we find angle C is 104.1 degrees. And because we found multiple things here, we're just going to do a therefore statement to sum up what we found. So angle C is 104.1 degrees. Example number 2. Now we want to solve triangle ABC. So we need to find all the missing angles, all the missing sides. So starting, we take a look at, we notice we do have side angle. So again, we're going to take a look at, first of all, how many solutions we can have. Angle A is less than 90 degrees. We know that A is shorter than B. So now we have to take a look at B sine A. So we're going to calculate the height of what this triangle would be. So B, 42 times the sine of 37.7. And when we do that, we get 25.68. We'll notice that A is greater than 25.68, which means that there's going to be two solutions. One that creates our acute triangle and one that calculates or has our obtuse angle. So, first triangle we're going to solve for, we're going to have our ABC, and we've got angle A is 37.7 degrees, angle or side A is 30 centimeters, and side B is 42 centimeters. So notice it doesn't matter how we set this up, where angle A and angle B are, as long as we label appropriately. So we've got our acute angle here. So now looking at solving, we need to find side C, we need to find angle B, and we need to find angle C. So starting with, we're going to use our sine of A to find angle B. So sine B over 42 equals sine 37.7 over 30. Taking our 42 over to the other side. And remembering we do our inverse sine once we get our decimal to figure out that angle B is 58.9 degrees. Again, remember we're going to 1/10 of a degree this time. Well, now we know that angle C then is equal to 180 minus our 37.7 minus our 58.9, which means that angle C is equal to 83.4. Now we still need to find side C. So now we're going to do side C over sine 83.4. We're still going to use our A ratio, just because we knew that was given information, we know that it's correct. So C is equal to 30 times sine 83.4 divided by sine 37.7. And rounding again to 1 decimal place, we know that side C is equal to approximately 48.7 centimeters. Okay, so that's one solution. We still need to do our second solution where we have our obtuse angle for angle B. So we're going to have here where we have our side coming down and meeting up, creating an obtuse triangle. So side A is still 30. Side B is still 42. And angle A is still 37.7. So now what we have to do though, so angle B is now going to be the supplementary angle. So what it was in our first triangle, we're going to find the obtuse angle in our new triangle by subtracting it from 180. So in our second case, angle B is 121.1 degrees, and we know that. Well, now again, we can calculate C. C is going to be different from the first one, obviously, because we have a different angle B. So minus 121.1 minus 37.7 means angle C is going to be 21.2 degrees. Again, we still have to calculate C. So C over sine 21.2 equals 30 over sine 37.7. So C is equal to 30 times sine 21.2 over sine 37.7. So C, once we figure that out, is equal to approximately 17.7 centimeters. Okay, so you can see if there's two solutions, it is a fair amount of work to find out, but we do have to do all of that because there are two possibilities unless we know what angle B is. Then it's pretty straightforward. Don't forget that we want to do a therefore statement. So angle B is equal to 58.9 degrees. Angle C is equal to 48.7 degrees. And side C is equal to mess that up. Side C is equal to 48.7 and angle C is equal to 83.4 degrees, or angle B equals 121.1, angle C equals 21.2, and C equals 17.7. And sorry, I'm running out of space here. Hopefully you have a little more room than I do, but you get the gist of it. Okay, so today you're going to go back and do the questions that you didn't do yesterday, but you are going to actually